Hello. My name is Dmitry Ustalov. I'm from the same university as the previous speaker, exactly from the Ural Federal University. And the topic of my talk is an open source on-demand server for human computations. Yesterday, I have attended the EIRG workshop, and I'm glad that that in Europe people care for open data, for open science. So we do. And one of highly important topics is crowdsourcing, and such systems, such crowd systems, and their results, their applications should be open, and this is the topic of my talk. So you have probably been familiar with this image. So this is reCAPTCHA, a famous CAPTCHA service that allows a computer system to distinguish you from some bot or robot. And one of the key features of reCAPTCHA is that it helps people to read books. One of the words computer generated. Another one is a word which has been took from optical character recognition system. And when you type both words, you help people read books and parse them into structured text. So here you can see the outline of my talk. Let's proceed. First of all, you should be familiar with the Turk. In 19th century, in 18th century, there were automatons, chess automatons in particular, when some wooden construction that can play chess. Exactly, this construction was operated by a human, which being inside this automaton. So a person may come here and start playing, and this wooden robot will play too. This is very similar to the concept of crowdsourcing, with actually a viable technique for collaborative problem solving. So, but running crowdsourcing tasks is obstacled because these platforms are closed and these workflows are not obvious. And my goal is to simplify this process. So there are a lot of genres of crowdsourcing. You may know Wikipedia, which is one genre. You know some games which can be played with some pipers and in order to produce data or solve some problems. And there are a lot of mechanized labor projects which you may know. For instance, Mechanical Turk. This is the form of question answering. So you see the question, and your goal is to provide a correct answer. So just a simple questionnaire. You fill it, you send it, and you get some benefit after that. There are a lot of approaches for controlling crowdsourcing. So crowdsourcing is a workflow when the requester proposes some problem. After that, there are a lot of workers trying to address this problem, and after that the answer is getting aggregated. There are three important steps. First of all is task allocation, then answer aggregation, and work ranking, which is depending on the answers. So this pattern is actually pretty common, so implementing it may be pretty useful. And here I designed a system which is pretty similar to prediction.io and metric approximation system provided by some vendors. I separate the application layer from the engine layer. Here it comes. So we have some use case. You are the requester. You just propose a task. There are some graphical user interface, the application, and they use your engine, actually our engine too, communicate. So this system is implemented as a web service that has a RESTful API in Java, which is a good battle-tested technology. I'll skip some technical details, but in order to make the process more dynamic, we use a dependency injection and some sophisticated technologies to make the initialization and processing process more configurable and flexible. So actually we have implemented some approaches for worker ranking, for task allocation, and for answer aggregation, which are demonstrated on the screen. There are some pretty obvious scenarios of using of the system. And here comes the graphical user interface that makes it possible to control the process. So you can see dynamically how many workers do you have, how many people do actually solve the job, how many tasks do you actually have, how many answers have you received, and to use some interfaces, to use some facilities to control the process. The system is open source. You can download the source code, and at the moment it's possible to run the system on the cloud, on your private cloud, on the public cloud, using a systemd-based deployment approach, which is pretty popular right now. So in order to check how the system works, it has been used two things. First of all, some tests which are actually passing, and the actual evaluation on the real-world data. So we took the pretty popular right now RUSSE dataset, which is available right here, and we re-implemented the system, and the system worked actually pretty fine. So the system is open source. The data which you can run the crowd processes, and you can easily gather the data to solve your problems using on your own infrastructure. And this is good because it can facilitate your results. It can make it possible to do your job faster and more rapid. So I'm highly interested in collaboration with some projects which tries to create some open data to solve some data gathering problems, and I'm glad to do something collaboratively. Okay, that's it for now. Thank you for your attention.
Thank you, Dmitry. Please, question?
Yeah.
One of the problems with these type of systems, if you use them in real life, is always that how is the quality of the answers? Is there are there ways in the system to automatically check that, for instance, someone is not providing random answers, or it's not a mechanical Turk providing the answers instead of someone doing a real answer? Are there checks in the system?
Yeah, this is a good question, and one of the major problems of the mechanical Turk style of crowdsourcing is the stability of answers. So there are some approaches which tries to address such a problem. For instance, you can see actually this slide. The goal of this system is to make it possible to you using some approaches that are battle tested in the appropriate tasks. There are approaches which can implicitly infer some answers from the some correct answers from the data that crowd workers have provided. And our goal is to implement these approaches and to make it possible to evaluate your data, the data you have gathered, with to see which approach fits your job better. And yes, there are approaches which makes it possible to infer correct answers from the data you have.
More questions?
Yeah.
In your title, there is a human calculation or
Computations, yep.
Could you explain what does it mean, particularly in your presentation?
Yeah, sure. If you will open the Mechanical Turk website, you will see a funny logo. You will see a funny motto: artificial intelligence. This is the key actually point, the key benefit of crowdsourcing. For instance, it's a mechanistic approach from, if you'll use some philosophy terms, when suppose you have to create an face recognition software, face recognition algorithm. You can spend some money, and suppose you have about 1,000 images. It's pretty not so big number, not so small number, but 1,000 images. You can spend some money and to write and to implement a face recognition algorithm. You will spend a lot of money for programming and testing your system. But you can take crowdsourcing. You can upload your images to Mechanical Turk and ask workers who wants to participate in this kind of study to answer which person is depicted on the image. And a typical price for the answer on Mechanical Turk is about 1 or 2 cents about 5 cents, and it's much cheaper than to write a full stack face recognition system. So here we have an analogy. Human computation, so you can use humans instead of computers, and they will provide the similar results. This is just a term.
So manual computations, something like this.
Yep.
There is a person, hybrid, yeah, who is performing some computations and simply put it as input in your system. And you show it to others as a result of your computations.
Yep. Yeah, you just switch humans to computers to humans and use their output for your own purposes. Thank you.
Thank you very much. Please.
Thank you.
Thank you.